Next topic is basic loudspeaker. We have progressed a long way since early designers fixed a crude horn to a telephone earpiece to make the first loudspeaking telephone. The science of loudspeakers has been refined to the point where the response of a drive unit, at least at low frequencies, can be predicted with great accuracy. Ideal loudspeaker. There are a number of interrelated factors that must be considered in designing transducer for converting electrical energy into acoustic energy. These include electroacoustic efficiency, uniformity of frequency response, linearity of amplitude response, transient response, durability, and cost. An ideal loudspeaker would have an electroacoustic efficiency approaching 100%, and it would have an acoustic output response that is dependent on frequency over the entire audible range. An ideal loudspeaker would introduce neither harmonic nor intermodulation distortion into its output. It would faithfully reproduce transients as well as steady input signals, and also it would be capable of producing a non-directional radiation pattern. The speaker system itself can be divided into three functional parts. The first one is the electromagnetic part, which consisting of the voice coil and the field magnet. Audio frequency electric current in the coil causes mechanical motion of the cone or diaphragm on which it is mounted. This part is often referred to as the driver or motor of the system. The second one is the mechanical part, on which the driving coil is usually mounted and which is set into mechanical motion by the audio frequency electric current in the driving coil. And the last part is the acoustic part. It transmits the sound energy developed by the mechanical part of the area served by the system in the most efficient and faithful manner possible. There are three types of speakers in modern use. First one is crystal, second one is electrostatic, and the third one is electrodynamic speakers. Crystal loudspeaker. Rochelle salt crystals have the property of becoming physically distorted when a voltage is applied across two of their surface. This property is the basis of the crystal type of speaker driver. The crystal is clamped between two electrodes across which the audio frequency output voltage is applied. The crystal is also mechanically connected to a diaphragm. The deformations of the crystal caused by the audio frequency signal across the electrodes cause the diaphragm to vibrate and thus to produce sound output. Crystal speakers have been impractical for reproduction of the full audio frequency range because the input impedance is almost completely capacitive. Electrostatic loudspeakers. This type of speaker operates on the principle that a DC voltage between two parallel metal plates causes these plates to attract or repel each other. The amount of attraction or repulsion depends on the applied voltage. If one of the plates is a flexible metal, it will bend, but the amount of attraction and repulsion is not directly proportional to the voltage applied. The working of a typical electrostatic loudspeaker is shown in this figure. The practical speaker of today uses push-pull with a built-in setup transformer to work from the ordinary 8 ohm amplifier output tape. The polarizing voltage is applied to the center or movable plate through a resistor that keeps the voltage stable during variations in the signal voltage. The signal voltage is applied to the two outside plates because the diaphragm is centered between the two plates that attract it equally. There is no bending when there is no signal. Also, because of the push-pull action, the diaphragm can move twice as far in response to signal voltage for the same amount of comparison of the directional material. Dynamic loudspeakers. There are two varieties of dynamic loudspeakers. One is electrodynamic and the second one is permanent magnet speakers. Both work in exactly the same way. The difference is in their construction. The electrodynamic speaker has a soft iron magnet circuit, non-retentive of magnetism, around whose center leg a large multilayer field coil is wound. When DC flows through this field coil, it magnetizes the iron core. A magnet flux field directly proportional to the strength of the current through the coil is set up across the air gap. The iron core is not permanently magnetized. Only as long as current flows through the field coil, the iron core is magnetized. Permanent magnet loudspeaker. The most popular type of loudspeaker today is the permanent magnet dynamic type. Because of its comparative simplicity of construction and design, the precision that may be built into it, the ease which it is interfaced with other equipment, its easy adaptability to many different applications, and its comparative freedom for electrical trouble, the dynamic loudspeaker has found acceptance in all kinds of reproducing systems. It is found in smallest packet radios and is a major component of the most elaborating theater systems. The dynamic loudspeaker is shown in this figure. Thank you.